All right, welcome to your first video in Physics 50. This is Unit 1, which is Math and Physics, and it's really just kind of all the skills that you need to have to be successful kind of going forward. So the first thing we're going to start with is something super important to physics, which is measurement. So to measure, we're going to use instruments or tools such as rulers, scales, thermometers. And these instruments have two pieces of information that you have to be careful about. The first one being their accuracy. Accuracy describes how close the measurement agrees with the standard or accepted value. This is something that's out of your control. So instruments are calibrated to ensure their accuracy. The best example I can think of this is a thermometer. You have 20 thermometers in a room that's 20 degrees Celsius, and some are reading 21, and some are reading 22, and some are reading 19. It's that accuracy of the instrument, which again, like I said, is out of your control. The second thing is precision. So precision describes the exactness of a measurement. Now, this is going to all depend upon which instrument you're using, but typically the tool with the smallest division has the least error or uncertainty and therefore will produce the most precise measurement. So what we're going to be looking at is rulers that give you different degrees of precision. In other words, different divisions of their lines. So when we are looking at these measurements, we are going to be recording their precision to the correct number of significant figures. Now, an electronic or digital instrument, you just record it as it's displayed because they give you as much as they can give you for precision. What we're going to be focusing on here are the analog devices. So analog devices are things like the rulers and the thermometers. And what you have to know is that there's going to be given numbers. So there's going to be numbers that are known with certainty. In other words, these like division lines, these are known with certainty. And you always want to record to the last, or like to the most certainty that you can. So for example, if I was to look at this ruler, the last known line is this 3. So I know for sure this measurement is going to be 3 point something. Whereas if I look at this ruler, you've got 3 point. Now these division markers, there's 10 between 3 and 4. So 3.1, 2, 3, 4, 5, 6, 7, 8, 9, and then 4. So my last known marker here is going to be this guy, which is a 3.3. So right away you can tell that these instruments have different levels of precision because this one, the last known line, is in the ones column, and in this one it's in the tenths column. Then what we always do is we read one more past this last known line. And this is the most important part. People are usually pretty good at being like, okay, yeah, it's 3 and this one's 3.3. But in science, you want to show people that you knew the 3 for sure. So we go one more beyond that we're always going to have to underestimate. So if I look at this one, I would guess somewhere around here is 3.5. So it's less than 3.5. How much less, how much more than 3? That's up to you. It's uncertain. So some people might read this as 3.3. Some people might read this as 3.4, and that's totally okay. So this last digit here is always an estimation, and it can be different for every person. Okay, so here it says measure and report the length of the rod using a coarse versus a fine ruler. This is my coarse ruler. And what we wanted to do is we wanted to underline the uncertain digit. So this one that we've estimated, we are underlining. And then it also says, and again, this is just starting the conversation, how many significant figures does the measurement have? We're going to have a huge conversation on significant figures in a minute. But I want you guys to agree that this number, I've written down 2 digits and they're both significant. So we're going to say that this has 2 significant, if I can fit it, digits, where 1 is certain and 1 is uncertain. When we look at this next ruler, this is more of a fine ruler, we said that we knew for sure this rod is going to measure at least 3.3. So it's somewhere between 3.3 and 3.4. And again, this is going to be an estimate. I would say, like, if I look at this, I'm going to say somewhere around 3.36 because, this would be 3.35 in here. In fact, maybe I would even say 3.35. I'm not sure. Some people might say 3.34 3.4, some might say 3.37. It doesn't matter. This last digit is always an estimation and it's based on you. What's happened is that we've gone from 1/10 of a precision to 100th precision. So instead of 1 decimal place, we've got 2 decimal places. But it is known that that second decimal place is an estimate. But we would say now that this has 3 significant figures because I wrote down 3 digits. I feel like this pen's really thick and it's hard to write. Okay. So now what we're going to do is we're going to practice just this. So I've got 4 more rulers, 2 thermometers, and kind of a speedometer type thing to read off of. So what we're going to be looking at here is reading these measurements with the correct precision, and then also just guessing. And again, this is just a guessing because significant figures are going to be way more in detail in a bit, but kind of guessing, well, how many significant figures do you think this measurement has? So for this first one, I mean, you're welcome to pause the video and try these 3, but we can do these 3 together as well. So, this is 0, and then the next known line is 100. So how much precision can I read to? Well, not a lot. I actually have to estimate the tens. So, if this is 50, I can only guesstimate that this is about 20, right? 20 centimeters long. And this is actually my estimate. So if you had to look at this, how much significant figures do you have? Now the 0 had to come along for the ride, so this is just 1 sig fig. Now that's going to make some more sense when we go later and we govern rules about zeros, but this wasn't 20 for sure. This is 20 uncertainly. I knew for sure it was between 0 and 100, so I guesstimated or I estimated this 20. And so I estimated the 2. So this is just 1 sig fig, and that's probably the hardest thing you'll learn, is that sometimes zeros are significant and sometimes they aren't. All right, let's look at this next guy. So for this next one, I know for sure I've got divisions of 10, 20, 30. So I know for sure that I can write 20, but then I can estimate my ones. So this course or this rod is somewhere between 20 and 30. So I'm going to say something like, I don't know, 21, 22, 23, right? Somewhere in there. It does not, matter. Because this time I've estimated the ones. So this one I estimated the 10. This one I estimated the ones. And so this one actually has 2 sig figs. Oh, there's my dog barking. Now let's go on to this third ruler. So for this third ruler, it's going one more beyond that. So if you look at your division lines, we've now got 20, 21, 22, 23, 24. So when I look at this one, I'm like, well, it's exactly 22. 22, but then I can estimate it's something between 22 and 23, so I'm going to estimate another digit. Now, this one gets harder and harder, especially because the picture gets blurrier and blurrier. I would say 22 point, I don't know, 2, but it could be 22.3, 22.4, it's kind of up to you. But this is my estimated digit. Now, this one is going to have 3 sig figs. So the sig fig things, don't stress. We're going to focus on that more in like 2 seconds. But just making sure you understand that when you're measuring, you go for your last known line and then go 1 beyond that. Now, I haven't mentioned this. There is a rule that when you are estimating, we can always do this, like we can measure the uncertainty. It's usually half of your last known division. So for this one, it's a 1. So you're allowed to be within plus or minus 0.5. So they give you a huge breadth of like space. This one would be plus or minus 5. This would be plus or minus 10, or sorry, 50, I guess. And then there's another way of doing it where you take a percentage of what, your division is compared to the space and all these things. But for Physics 50, all I'm looking for is that you can go last known line and then 1 place past that. So maybe you're ready to pause the video and give these ones a try now. So for this one, I've got a 15 and a 16. This is 15.1, 2, 3, 4. So I'm going to write down for sure 15.4. And now I get to estimate a second decimal place. So I'm somewhere between 15.4 and 15.5. I don't know, 15.46. 15.47, 15.48. I'm not sure. Okay, again, it's an estimate. You can write whatever you want. And if you think about this one, you know, it's going to be plus or minus 0.05. So you've got a lot of space to work with. And so for this one, I would say that this one has 4 sig figs. All right. Looking at the next pictures, this one's our speedometer. So it's the same as the one before. We can look and it's 3.1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So my last known line would be a 3.8. And then I get to estimate past that. I would say about 3.85 actually. That one's looking kind of right in the middle. But if you had 3.84, if you had 3.86, you're absolutely fine. Okay, because this is your estimated digit. And we would say that this is 3 significant figures. Okay, we look at our thermometers here. We've got a 20 to a 30, and again, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm going to say my last known line is a 21, and then I get to say 21.3, right? Or 21.2, or 21. I don't know if I'd say 4. Well, maybe 21.4. So we've got this last digit here that is an estimate. Okay, it's an uncertain digit, and we would say that we measured to 3 significant figures. All right, this last one here, we've got 21, 21.123. And then we get to go one more past that. So I would say 21.32 maybe. And again, if you had 21.31 or 21.33, you'd be absolutely fine because this last digit is uncertain. And we would say that these are all 4 sig figs. So the one thing I really want to point out with this significant figure thing, if you don't understand it yet, don't worry, you will. But the one thing I really want to point out is that it doesn't matter which measurement I give. It doesn't matter what estimation I make. It's all 4 sig figs. Okay, when I'm reading these instruments, it is known how to read them. No one's going to read this and be like, well, I got 3 sig figs, and someone else be like, oh, well, I got 4 sig figs. We're all going to get the same, because when you're reading a device, you go for your last known line and then you estimate one beyond that. All right, have fun.